In this video we're going to look at asymmetric information and in particular adverse selection. So a typical adverse selection market is an insurance market, so that's the market that we're going to consider here as well. So we're going to assume that consumers have a utility function where x is income, which is of the form x to the power rho. So that's going to look like this, where we assume that rho is smaller than 1. Yeah, so rho is actually between 0 and 1. So that means that the utility function is concave and that the consumers are risk averse. So they would like to buy insurance if it's not too expensive. So let's create the consumers. So we're going to assume that they have an income equal to 1.1. If they have an accident, they have a cost of 1.0. And we're going to assume that the rho from the utility function is going to be 0.1. If you're working on the Jupyter lab, Jupyter server, or you're using a Jupyter notebook and you would like to use Greek letters in Python, the way it works is you type the LaTeX name of that character that you want to use and you press the tab key. And that should give you the Greek letter rho. In Emacs it works slightly differently. So these are the parameters. So now I can define the utility function. So that's going to be x to the power rho. So in Python, to the power is these two stars. And now we need to define how consumers differ in the risk that they run of incurring the cost C. Yeah, so we're going to use for the probability to incur the cost C, we use the vector pi. Again, we're going to use TensorFlow here, but now we're not going to use a normal distribution, but a uniform one, because we want these probabilities to be between 0 and 1. We're going to draw 50 consumers, and the lower bound and the upper bound are going to be 0 and 1 from the uniform distribution. And to give it a nice representation, we're going to use NumPy. And now we're going to sort this vector. Yeah, so the first, I made a mistake. TensorFlow is not defined, so apparently I didn't import this. Import TensorFlow SGF. Here we go. So we sort these probabilities pi, so that means that the first element in this vector is the individual who has the lowest probability of incurring the cost C, and the last element in pi is the person which has the highest probability of incurring this cost C. So now we can define insurance demand and supply. So we're going to define a function insurance demand, and insurance demand is going to be a function of the sigma, which denotes the price of the insurance contract or the premium. And basically the question we'll be wondering about is who is going to buy insurance. Well, if I do buy insurance, my utility is going to be uy minus sigma. So this is what I get if I buy insurance. So then if I incur the accident, I don't really care. I don't really care about the cost because it will be covered by my insurance. Yeah, so we're assuming here that insurance covers the whole cost. Now if I do not buy insurance, what am I going to get? So first I run this probability pi that I incur the cost. So I have an accident, for instance, or I fall ill and I need treatment. So that will give me utility y minus c. So here I incur the cost. And of course with probability 1 minus pi, I just have my utility of my income. Why? Because I don't incur any costs and I didn't pay any insurance premium. So these are all the individuals for which it is the case that it's actually beneficial for them in expected terms to buy insurance. So these are Boolean, so this is a series of zeros and ones, where 1 means this inequality holds and it is beneficial for the person to buy insurance. So if I sum these, I'm going to have the total demand for insurance in this economy. And similarly, I can also define insurance supply. And here I'm going to define it as a function of the quantity. So I'm going to assume that this market is perfectly competitive. So insurance companies are willing to supply insurance at the expected cost of insurance. So again, we're going to have this idea that who's going to buy insurance if the insurer is selling 10 contracts. Well, if the insurer is going to sell 10 contracts, it will be to the people with the highest probability of incurring the accident, because these are the ones who most want this contract. So I can look at the probabilities of the risk for these people, so pi, and it's going to be minus q, and then all the way up to the end. Yeah, so if you're a bit wondering about this notation, you can simply try this out for yourself. So you can look at numpy, a range, let's say 10, and we're going to do minus 3 with a colon. So what does it give me? It gives me the last 3 elements of this vector numpy range 10. Yeah, so numpy range 10 is a vector with 10 elements. The first element is 0, the last element is 9, and minus 3 colon means we're looking at the last 3 elements of that vector. So here what we have is from the vector, these, I don't need these. From the vector pi, I'm looking at the last q elements. So if we're going to sell 10 units, so q is equal to 10, then the people that are going to buy these is from the vector pi, which is sorted, the last 10 elements. So the average risk is going to be the mean of this. So this is the average probability that you have to pay as an insurer, and C is the cost that you actually have to pay if somebody claims that they had an accident. So now we're able to actually plot demand and supply in this insurance market. So let's define the range for Q, which is going to be equal to 1 plus numpy range 50. I'll explain in a second why I have the 1 plus here. I have a range for sigma, which is going to be equal to numpy range going from 0 to 1.1 with steps of 0.01. So now I can plot insurance demand. I have to put this between square brackets, so we're going to have insurance demand, which is a function of sigma. And now I want to know what insurance demand is for each sigma in the range of sigma. And I'm going to plot this against the range of sigma. And let's say that we're going to plot demand red. Now we can also plot insurance supply. So now I'm going to specify the range of Q, capital Q, square brackets here, and this is going to be insurance supply as a function of Q for Q in range Q, and I can plot this as a blue line. And then we can do PLT show. And here we have our insurance demand and insurance supply. So the first interesting observation is that insurance supply is downward sloping. Yeah, so insurance supply is this blue line, so it's actually downward sloping, which is a bit surprising because usually, of course, supply is upward sloping and demand is downward sloping, but here both these curves are downward sloping. And the reason why I use the 1 plus here is because I identify the people that actually going to buy insurance as the last Q elements from the vector pi. So Q needs to be 1, 2, 3, etc. So that's why we start here at 1 plus numpy arrange, because the numpy arrange itself starts at 0. And here you see the average cost for the insurer if it sells 10 units, for instance, because these will be the 10 people with the highest probability of incurring the accident, of incurring the cost. So this is going to be the average cost if you sell to 10 people, then the average cost when you sell to 20 people, etc. So supply here is downward sloping, because the more people that I add on the insurance contract, the cheaper the contract is going to be, because I'm adding better and better risks, and therefore on average the contract becomes cheaper. Then I have the demand curve, that's downward sloping for the standard reason. So at the high value of sigma, only the people who have very high probability of incurring the accident will actually buy insurance, and as sigma goes down, more and more people are willing to buy insurance. The equilibrium in this market is determined by this intersection point, which is the maximum number of people that can be supplied with insurance at a cost that covers the expected cost for the insurer.